for now, I'm going to do a very short presentation on Windows RT. So, Windows 8 RT, desktop security in particular. I'm going to go through a few case studies about ways of breaking Windows 8 RT desktop security, and also just a little bit of changes in Windows 8.1 RT, which have tried to or broken some of the existing attacks. Now, for the few people who don't actually know what Windows RT is, it's the ARM port of the Windows NT operating system. So if you've used the Surface, which I'm sure pretty much if you work for Microsoft you probably even have one, outside of that possibly fewer people actually own an ARM Surface, but thank you. What a pain. Okay, so now the strange thing about the ARM port is you would think it was probably going to be designed to compete with the iPad, so it's going to only use the immersive applications, the full screen, what they used to call Metro applications. But obviously I don't know the history behind it, but obviously Office, for example, is not yet ported across to the immersive application format. So RT actually has a pretty much full Windows desktop or Win32 style desktop installed, ported across. It just seems to just work, and you can access all manner of interesting things on the desktop. But that was obviously not considered to be a good thing, so Microsoft went and tried to lock it down. Now, you can deploy side-loading your Metro applications or your immersive applications as much as you like, but if you want to run code on the desktop, so if you want to run your traditional Windows applications, then all these executables must be signed by a Microsoft certificate. They also enforce this from the kernel, so it's not like it's a user land enforcement. It's enforced through the code integrity mechanism, which has been around since Vista, was added for kernel signing, and it's been extended to do user mode signing as well. But in order to try and limit the attack surface of the desktop, they made some modifications to some of the desktop applications. For example, Office no longer has VBA, Visual Basic for Applications, because you could get it to call arbitrary DLLs, for example. And this is all implemented through deploying a policy through secure boot. So when, say, the Surface has its secure boot, which is signed by Microsoft keys, there's a policy in that the secure boot information which says this is the only thing you're allowed to actually do. This is the only code you can run on the desktop. So bearing that in mind, I'm going to go through these couple of case studies where the desktop really was not a suitable place to try and lock down. There was too much history involved with the desktop and the way in which it interacted with Windows. That makes it very difficult to secure it and prevent people running arbitrary code. And the first case study is administrators. Your Surface RT, you can get admin rights on. And traditionally, admin rights were considered to be, effectively, you're a god on the operating system. You can do almost anything you like. That changed slightly with Vista, because x64 systems, you needed driver signing, so it was, I suppose, you were getting less power than you used to be able to. But it's still actually, there was always an argument that if you could get administrative rights on a Windows machine, then there was no security left. But someone noticed that there was a long-standing bug. I think Alex Ionescu and a few others found it originally, where certain parts of the operating system trusted administrators more than, or certain parts of the operating system trusted each other more than other bits. So this particular bug was in CSRSS, which is the Windows runtime subsystem, and it could do some special kernel calls which no other application on the system could do. And one of these calls, it turns out, allowed you to decrement arbitrary kernel memory locations. And someone thought, okay, if we can do this, if you're an administrator on that box, you can inject code into CSRSS. You couldn't do that if you're a normal user to elevate your privileges, but you could do if you had admin rights. And by taking that bug, you can then modify the in-memory data which represents what the current signing level for desktop applications is, and break out of it and create your own jailbreak. So various enterprising people came along with a fully sort of just double-click a file on your desktop and you jailbreak your Surface RT, and then you can run any desktop application you like, as long as you recompile them to use ARM code, of course. Now, I was not actually involved in any of this, but after someone had produced the jailbreak, I thought, oh, maybe buying a Surface RT is actually worthwhile, and actually sort of picking one up for a sort of nice, small, portable machine. Of course, 8.1 is now out, so while we haven't actually fixed the bug, so CSRSS can still modify kernel memory, I believe, what they have done is CSRSS is now a protected process, and protected process is a mechanism to prevent user mode applications gaining access to certain protected processes. It used to be for DRM purposes, but nowadays in 8.1 they've added it for third-party AV and some of the system processes, CSRSS, LSAS. They can all now be protected from other user mode applications. The other thing which was changed is this flag in memory, which indicates what your current signing level is now protected by PatchGuard. So if you modify this code integrity flag to allow any application to run, in theory PatchGuard will notice and your machine will blue screen with your typical PatchGuard error. Now on to something which, once I'd bought that Surface RT, I thought, the jailbreak's great and all, but maybe I want to play a bit myself, find another way of getting code to run on the desktop. And this is where the second sort of assumption of Windows, which used to hold true, but perhaps no longer does on a RT desktop, is that the desktop environment comes with a massive number of executables which you can run as a normal user. Now, if you found a bug in command line processing, for example, maybe it does a Stack Overflow, you could argue that, well, unless it was remotely accessible for some reason, then there is actually no security vulnerability there, because you're only attacking yourself at that point. So it wasn't a major issue. But now when you can't get code to run on the desktop, suddenly bugs in applications on the device suddenly become more significant. So being a .NET kind of person, I had a look at the applications. I first tried to compile my own C# code. It interestingly does the compiler on the machine, but you can't actually then run the file because it's not signed by Microsoft, at which point it doesn't work. But one thing I did notice is there's PowerShell. And PowerShell, if you've not used it, is a sort of scripting environment, command line environment, which uses .NET as the back end, supports the ability to interact with the .NET runtime and run your own arbitrary code effectively. Now, I thought, okay, let's have a little poke, see if I can do anything interesting. And so, for example, I tried to use the new object commandlet, which says, create this arbitrary .NET type. And if you do that on a Surface RT, you're greeted with this horrible red text, which says, sorry, mate, you're clearly not allowed to do that. You can't create this type in this language mode. Okay? And at this point, I may have just given up because I couldn't be bothered. But obviously, I wouldn't be here if I just gave up at this point. So, I got out Reflector to have a look at the binaries themselves and dig around in them a bit. And I eventually traced that error down to effectively this piece of code. It's hard to see probably, but what this code is doing is it's looking at like a global language mode. And this is sort of referred to in that error text I just showed you. And this says, if we're in this special constrained language mode, whatever that happens to be, do a secondary check and see whether you're actually allowed to do that operation. So in this case, are you allowed to create that particular type? So there's certain core types which you can create at your leisure, but obviously system diagnostic.process is not one of them. So okay, that seems all very well and good. I wonder, is there this is something new for PowerShell on RT. So I ran the jailbreak, tested my things again, and found that no, it is actually specifically being set based on the signing policy. If you turn the signing requirement off, all of a sudden PowerShell becomes the fully unlocked version and you can do anything you like. So, you can look at MSDN, and MSDN describes the PS language mode enumeration. And it has full language, so you can do anything, restricted language, and obviously constrained language, which is what it was checking for, is apparently to be documented, to be determined. I'm not quite sure what the acronym means. Not very helpful. But it does at least mean, if it's a global state, can I set it to another language mode somehow and get it to bypass the security checks? So after a lot of digging, a lot of following references around, looking at the PS language mode, I came across this piece of code. And it's a pretty horrendous piece of code, but what it is doing is it's building up, it's in the parsing process, and it's building up a expression to execute some code in a restricted context. And it's capturing the old language mode, running some code underneath that, setting restricted language mode and running some code under it and then reverting back the language mode. And obviously, whoever designed the language mode originally obviously didn't necessarily consider that, well, there's certain areas where constrained language mode, which you're trying to do security enforcement in, gets converted to restricted language mode, which, while it says it's restricted, is actually obviously slightly more permissive than constrained mode. So I knew I was onto something, so I had a look at the particular code in question. And this is data sections. And it's sort of like it's described there as a mechanism to do sort of read-only properties. You can use it, for example, to load up localized strings into your PowerShell scripts. And it runs in restricted mode just to kind of stop you doing stupid things. You can't like accidentally put in something which changes the person's program when it just loads some properties up into the PowerShell session. So I tried that, put it in a data section, and it didn't work. I get a nice big red error again. But interestingly, the error message is now different. So now it's telling me that this particular command, this new object command, is not actually allowed in the data section, or not allowed in a restricted language section. Okay, that sounds interesting. So you can go back to the help file, and you see that there is an optional command, or optional argument called supported command. I wonder what happens if I use that. Well, suddenly it starts working. So what can I do with that? Well, I found a circuitous route of getting fully privileged PowerShell to run. So that was one thing. You could then run anything you liked without worrying about code integrity. But I was kind of interested in trying to get a real .NET assembly to load. Something I've written in C#, because I'm not necessarily the greatest PowerShell programmer in the world, but it'd also be easier to deploy, and maybe I can even load existing .NET applications because they're all running using intermediate language, or they should be, unless you're using sort of a mixed mode binary, which means that the JIT, so the just-in-time compiler, should emit ARM code, and as long as you've compiled your DLL or your executable to use this format, you should be able to use it any way you like. So I thought, okay, I can now call any method in the framework, in the .NET framework, and so I'll call assembly.load, which is how you load a DLL or an exe file into memory and run something. But of course, that doesn't work. And the reason it doesn't work is because assembly.load does an image load. It tries to load the DLL as an image. And we know that the signature checks get in the way at that point. But fortunately, because .NET doesn't really need these DLLs, it's not actually running native code, in a sense. Actually, what you can do, there's a function to load an assembly from a byte array. So instead of loading it from disk, where the signature checks will get in the way, instead you load it from a byte array. And surprise, surprise, that actually works. So you can take your existing .NET DLL or executable, load it into memory, and load it using this assembly.load function. Now we know that I would be failing in my duty as a security researcher if I wasn't able to put a proof of concept inside a single tweet. So I went on a bit of a size coding thing to try and just get that bootstrapping of an arbitrary DLL working in 140 characters. Obviously I succeeded. In this particular case, so the first line is just a sequence of operations to read the file into memory, load it using my assembly.load function, and create an instance of an arbitrary type in that DLL, which then will run any code I like, just as a proof of concept. But interestingly, in this particular case, if I tried to run that line, it would cause an error. It'd say, well, you're clearly not allowed to do that. So instead, I bootstrap it all through this using the history. So because of the restricted language mode, I couldn't actually run that entire line within the data section itself. But even though that first line fails, it stays on the history. So it's the last command you ran, even though it never actually ran. So IHY is an alias for the invoke history command, and running it bare invokes the previous command you tried to execute. So by doing this, you bootstrap your code, and obviously now it all fits nicely into a tweet. I did have a bit of problem doing this, actually, and if anyone is here from Twitter, I have a major gripe in this regard for my development of proof of concepts. The web page tried to, or also the clients, they assumed system.reflection.assembly was a URL. And it would try and auto-convert these URLs to the sort of shortened bit ly type links. It seemed that actually the length of the shortened URL it thought it was going to convert it to was longer than the URL which it claimed it was replacing. And so even though my nicely, I think it was 139 characters long, it thought it was 150 because it was trying to do autoconversion. Of course, when you actually submit it and you reduce it a bit and you get it submitted, it then doesn't bother to convert them to URLs at all. So I don't know whether there's an easy way around that, but it didn't really matter in the end. So how was that changed in 8.1? Well, for a start off, they actually fixed the bugs. Now, when I sent this off to SecureAt, it took about 9 months, I think, or 7 months, something like that, before I got a final answer of, no, we're not going to fix it. It's not really a bulletin class release because it's not a security boundary. It's probably the usual turn of phrase which is applied to these sort of scenarios. So it wasn't fixed, but unsurprisingly, it was actually fixed in 8.1. So you now, if you try to do this particular exploit, it gives you a horrible, you're not allowed to do that, go away. I did actually submit a second bug at the same time, which you could possibly repurpose by copying the files from 8RT to 8.1 RT, but they've also added new checks into so they've added new elements to the certificate attribute of signed files, which mean you can't take a 8RT file and apply it to 8.1 RT file. So that's a bit of a shame, but of course, where is the future of desktop security on Windows 8 RT or 8.1 RT? Is it secure? Well, obviously not. This is obviously a demonstration of a jailbreak on RTM 8.1 on a Surface RT, and it seems to work quite happily.